Okay, now what I have with me here are two different structure. So could you make a quick guess that what is this structure represent? What does the other one of this structure represent? Well, this structure, if you see closely, it resemble actually the metallic bonding. So this is actually a structure of a metal, as you can see over here. And the next one is actually a structure of an ionic compound. How do I identify that as an ionic compound? As you can see over here, that there is clearly a positive charge and a negative charge. So these are the ions as within a ionic compound. So if they even ask you in this question, what are all these negative? The negative is actually, of course, my anion. The positive, of course, are my cation or the positive ion. Now the other side over here, because it's metallic bond, this small little circle actually represent my delocalized electron or free electrons, and the positive here actually represent my cation or my positive ion. Okay, now they asked this question: metals and ionic compound can both conduct electricity. Describe how metals and ionic compound conduct electricity. Now we all know that metals conduct electricity both in solid state, molten state. Why? Because in these two states, the electrons are free to move. Basically, for a metallic bond, you must understand that for any metallic bonding, they have this thing called free electrons. So in these two states, definitely all metals can conduct electricity, as we all know, because the electrons are free to move and carry charges. Now, for ionic compound, we need to understand that they can only conduct electricity in molten and aqueous states, because only in these two states the ions are mobile. And we need to also mention that in solid state they cannot conduct. Why? Because the ions are actually held by strong electrostatic forces of attraction. Therefore, they cannot conduct electricity. I hope you get this. And please bear in mind that for ionic compound, they can really only conduct electricity in molten and aqueous state, because the ions are mobile and they can act as charge carriers. Did you get that?